Hey guys, Mr. Rice is here with you, and I wanted to go over a few examples of using for a sampling distribution of sample proportions. So if you viewed my previous video with sampling distributions, I give you an example of awesomeness and how we can look at a sampling distribution as opposed to a sample distribution and what that sampling distribution looks like. I give you a short example, but I'd like to do two more examples for you so you can see at how we would use a sampling distribution of sample proportions. So let's take a look. So I have here, let's suppose we're going to spin 50 pennies. I want to know what the probability that more than 70% of those pennies come out to be heads. So what we're going to do is, since we know that we've taken a random sample, we know automatically that since we're taking a random sample, we're going to use a sampling distribution. And so we're going to need to check our conditions for normality. So what we're looking for here is we're checking our conditions. Sometimes they're called conditions for inference, but basically what we're trying to do is see if we can use a normal distribution to model to model our sampling distribution of sample proportions. So first thing I'm going to do is label that P. P is my probability of success, or my population proportion. Q is my, so it's kind of like the proportion that we expect to happen, right? So 50% is what we expect. We expect 50% heads, 50% tails. Q is the probability of failure. So in this case, 50%. And my N is my sample size. I'm going to spin 50 pennies. So now I'm going to write my conditions out. So these are my conditions for inference. All right, again, we're doing inferential statistics here, guys. So we're doing sampling distributions. My first check is that I have a random sample of 50 pennies. And I really recommend that you write down what the context that you're dealing with. Don't just write random sample. I know in my previous video I just wrote random sample, but you really want to write down random sample of 50 pennies. The second one is our check for independence, or our check for less than 10%. So just to give you an idea, again, we're either looking for a small enough sample size so that we can assume independence. In that case, it's less than, our sample needs to be less than 10% of the entire population. Or we can say that each spin is independent of each other spin. So that's what we're going to say here. We're going to say each spin is independent. All right, it's independent of the previous spin. And so we have independence assumption, which is clear in this case. So let's take a look at our third assumption, and our third assumption is that we have a large enough sample size. And to check if we have a large enough sample size, we're going to check the expected successes. So the expected successes is going to be 50 times 0.5. We expect half of them to be heads, so that's going to be greater than or equal to 10. Remember that third check, that just needs to be greater than 10, greater than or equal to 10. All right, and then we're going to do 50 times 0.5 again, because that's Q, and we're going to get 25, which again is greater than or equal to 10. So we've got big enough so we can use a normal model to model our sampling distribution for a sample proportion. Okay, so in order to do this, for what we're going to be doing next, we need the formula for the z-score. So that's z equals p hat minus p over square root of pq over n. All right, so we're going to use that as our z-score formula for all of these. So here we go. P hat is going to be what's in our problem. So this right here, this is p hat. P hat is 70%. So then we're going to go ahead and find our z-score. That's the first thing we need to do. First thing we need is do. By the way, I have no idea what animal noise I just made. I think I was going for an elephant, which clearly that was not an elephant. That was more like a, I don't know, screaming goat. Or I guess maybe if I just screamed, then there would be a screaming goat. Get it? Greatest of all. No, I'm just kidding. I'm not that full of myself. Okay, so we got p hat minus p over square root of pq over n. And that's going to compute to 2.83. And then we're going to want the probability that z is greater than 2.83. Right here, see, more than More than is give us the greater than symbol. You're going to want to find that on your Z table or using technology of some sort. I usually have my students in my college course look on their Z table, but if they also have like a TI-83, 84, or a TI Inspire, they can use that, or a Casio, they can use that to find this using normal CDF. But we're going to get 0.0023. And if you need a review on how to use a Z table, I've got another video on that. You can go check that out. All right, so what about less than 5 of them are heads? Now, in this case, I didn't ask for a proportion, and I do need to remind you. Let me look at my phone here. I have my solutions on my phone. I do have to remind you that when you do this, when you use this Z formula for sampling distribution for sample proportions, there should be no whole numbers in this except for n. N is the only whole number that you should have. Everything else should be decimals because we're talking about proportions, percentages. So we're looking for a proportion. So I see this in a lot of students. They put Z equals 5 minus 0.50 over square root of 0.5 times 0.5 over 50. And that is, one, it's completely wrong. You can't have 5. It's not 500%, right? The p-hat needs to be a percentage. So don't put a whole number right here. That's not correct, guys. Don't do that. Don't do it. So if they're giving you a whole number in the stem of the problem, what you have to do is you have to calculate p-hat by taking 5 over 50. So you're looking for the ratio. And that's going to give us, or the proportion, right? 0.10. We are doing sampling distribution of sampling proportions. So I'm going to get 0.566, which everyone knows if it's less than that, that is just a ridiculous Z-score. That's just like, what? You can't have a Z-score like that. So that's approximately 0, right? Such a small probability that this is going to happen. All right, let's take a look at one more example, and then I'll let you get out of here. I'm sure maybe you've put me at, you maybe go fast forward. I don't know. Maybe making me go really, really fast. Maybe I should talk really, really fast, see what it sounds like when I talk really fast. Okay, we're going to do the conditions first. All right, so we're going to write out our conditions. Our first condition is that there is a random, that we have a random sample. And then our second condition is that we have independence or less than 10%. Now, I don't know if all these supervillains are actually independent of one another. They could have been, captured together with the Avengers, so I'm going to have to use the 10% condition in this case. So what we'll say is, we'll say that 40 supervillains is less than 10% of all the supervillains in the negative zone. Third condition is my large enough condition, sample size large enough, so n is going to be 40 and p is 0.32. All right, I should have labeled those in the beginning. 0.32. Q is going to be 0.68. No, yes, 0.68, and n is 40. All right, so then I'm going to have NPQ here. All right, so now we're ready to answer these questions. Let's go ahead and say, well, this one again, no more than 15. So we need to find the proportion. P-hat is going to be 15 over 40. And so that P-hat is going to be 0.375. And then we'll use our Z-score or our Z formula from before. So 0.375 minus 0.32 divided by the square root of 0.32 times 0.68 and over 40. And I see a lot of like most students have problems putting that in your calculator. So if you're having trouble putting that in your calculator, put in the calculator and check to see if you got the same thing I got. What might need to happen is that you might need to put parentheses around the top. Normally what happens is students just forget the parentheses in a scientific calculator. That solves the issue. All right, so we're looking for the probability that Z is less than 0.75. All right, we're going to look in our Z table. We're going to find that to be 0.7734. That's it. All right. Let's do one last one. All right, so if 20 of those villains in your sample were sent there by the Avengers, would that be surprising to you? So, well, what is surprising? Well, in a previous video when I talked about things that are surprising, surprising is anything that's more than 2 standard deviations away from the mean. So if we found a Z-score and we found that Z-score to be bigger than 2 or less than -2, then we know that that value is going to be too far away, and it's going to be kind of strange or an outlier. So let's go ahead and first find p hat, because we're given a whole number and we want to make sure it's in decimal form, which is 0.5. And then we're going to go ahead and find the z-score. So 0.5 minus 0.32 over the square root of 0.32 times 0.68 over 40 is going to be 2.44. And sure enough, look at that. That is. So we would say yes. Yes, that would be surprising. Yes, I'd be surprised. Why? Because the z-score is greater than 2. All right, now if you want to know what that probability is, that probability of that happening, so the probability of getting more than 20 or more supervillains that were sent there by the Avengers is 0.00. There's actually a 0.7% chance that we would see 20 or more. Man, I think that's pretty surprising. So there you go, guys. Those are some additional examples on sampling distributions for sample proportions. We'll see you guys later. Bye.